So we start by writing our wave function psi as a product of a function of x, which we'll call lowercase psi, times phi of t. So the reason we do this is because when we partially differentiate this equation, we'll actually get total derivatives. So for example, if I do the time partial derivative of psi, we'll get the total derivative of phi in terms of t times by psi. And equivalently, if we do the second position derivative of psi, we'll get the second derivative of psi in terms of x times phi. So now that we have this, we can just plug this into our Schrodinger's equation, which will be much easier to solve since it's actually total derivative, not partial. So if we actually plug this into the equation, then rearrange, we get the following. We get I h bar times 1 over phi times the time derivative of phi, and this equals minus h bar squared over 2m times 1 over psi times the second derivative of psi in terms of the x, then plus our potential v. So if we observe that the left hand side is a function of t and the right hand side is a function of x, so this is only possible when both functions equal a constant and the same constant at that. So if we let the left hand side equal a constant, 1 over phi d phi by dt equals some constant e. So that's our first equation, and our second equation is going to be minus h bar squared over 2m 1 over psi times the second x derivative of psi plus the potential, and this equals e as well. So what we have on the bottom here, this is actually the time independent Schrödinger equation. So we actually can't solve this one at this very moment because we have no information on what our potential is. So the solution to this equation is actually dependent on the wave function and the potential that it lies in. But what we can do is we can solve this one. So this is actually just the first order ordinary differential equation, and the solution will be the exponential function of minus I times e, which is our separation constant, t over h bar. And this is going to be true for no matter the wave function or potential. So now what we can write, using these two equations, we can write that our wave function psi of x and t is equal to psi, which is our time independent Schrödinger equation solution, times by the exponential function of minus I times our separation constant times by t over h bar.